Hello and welcome to this video where we've come into random forest, hands-on using scikit-learn and Python that will use the heart.csv dataset, which I will show you later on in ISLR resources. Use random forest to classify if it's a heart disease or not. This will be quite interesting. We have talked about random forest in the theory session. Refer back to that to understand how random forest works, and remember that random forest is among the state of the art when it comes to machine learning algorithms. It works really well in tabular data. Make sure to learn about it and test it out. Without further ado, let's move on. I will show you where to find the dataset and then later on going into the code. So here I am in the ISLR homepage, statlearning.com, and here you find the resources, and inside the resources there's datasets, and inside there's this heart.csv. Download this dataset and then we'll move on to the code. Now I'm in Visual Studio Code, and let's start with the terminal. UVVNV to create a new virtual environment, the source then been activate, and now I've activated it, then UV-pip install. Let's see, what do I need to install? I need to install scikit-learn, of course, IPy kernel, since I'm in Jupyter Notebook. I need Seaborn, and Seaborn gives me matplotlib as well. Pandas I need, like this. Okay, done. That was super quick. Thank you, UV. Okay, let's create this, let's see, random forest. Random forest.ipnb. Here, markdown, random forest, change my Python environment to the virtual environment that we created, change this to Python. Let's start. From sklearn.ensemble, import random forest classifier, since this is the classifier that we'll work with. Import pandas as PD. Let's see, import Seaborn as SNS. Let's start with this actually. df equals to pd.readcsv, heart.csv, and it looks like this. Let's see, df.head. Okay, here we need to have index call 0, that this one becomes the index. We don't have an extra index here. Okay, good. Here now you can see that we have our dataset. And let's take a look into this dataset. df.info, we have 303. Here we see CA, we have a little bit of nulls. It's just a few values. I'll just remove them. Let's do df.drop na in place equals to true. Then we will do a count plot as well. Count plot data equals df, x equals to AHD, since this is the arterial heart disease. Okay, this is the one that we want to predict on. It's the target variable. Let's do hue equals to AHD as well. Okay, here you can see it's quite balanced dataset. And using df drop now, we have drop that we can see drop df.info. Let's do df info again. You can see that we have 297 because it deleted those rows that had the nulls. Let's continue here. Actually, we could do some feature engineering if we wanted. We could take a look into the heat map, correlation heat map. We could do pair plot as we have done in previous videos, but since I've showed it in previous videos, I won't do it again here. Instead, it's time to do random forest now, random forest classifier. In order to do that, we'll start with getting dummies, because we have a lot of if you take a look into df info again, you can see there's a lot of objects. In order to work with these features, we need to get dummies. df dummies equals to pd.getDummies, df drop first equals true, and then x, y equals to df dummies drop. Or actually, we can look into df dummies.head df dummies.head. Okay, now you can see here we have ahd yes, we have thal reversible, thal normal, etc. Here ahd yes, this one we want to take out as y. X comma y equals to df dummies and dot drop. We need to drop this ahd yes. Then x is equals 1. Then for y is just df dummies of ahd yes. Okay, then let's do train test splits from scikit-learn dot model selection import train test split. Here I'll just copy this code because I don't want to mess it up. We have x train dot shape x tests dot shape, and you can see it looks like this. Okay, we have 60 in tests. Okay, x train, let's look into the head here how that looks like. You can see here we have true and in the train the prediction will be true and false, and that's totally fine for us. Let's do model rf equals to random forest classifier that we imported before. We can make a random state here 42. Model rf dot fit x train. Note that we don't need to scale. We don't scale the data when we use a random forest, x train and y train. Then y pred equals to model rf dot predicts on our x tests, basically. Then we can take a look into y pred, and you can see there's a lot of false and true. It's a boolean, and that's totally fine. Now it's time for evaluation. Okay, in order to evaluate this, it's standard procedures from scikit-learn.metrics, import classification report, confusion matrix display. Then we will do like this. So let me see. Print classification report. Y tests, Y pred. This is how it looks like. Okay, this is the classification report, and now let's take a look into the confusion matrix. CM equals to confusion matrix of Y tests and Y pred. Then let's take confusion matrix display, comma display labels equals to no, comma, yes, and then we will have dot plots, and that is it. Now we have our confusion matrix and classification report. I've already explained this course in previous videos, but it looks quite good. Now let's move on to some feature importances. We have done that in decision tree, but we can do that in random forest as well. Model rf dot feature importances. You can see here are the different values of them, and we can do model rf dot feature importances dot shape. You can see that is 16, and also x train dot shape. You can see that it's also 16 here. That means that for each value here corresponds to each of the feature, how important those are. What you also can see is that if we can see this is an array. Model rf dot feature importances dot sum. You can see that it sums to this is 1, is rounding error, but it's basically 1. Then you can know that it's percentage of how important the features are. If it's 0.8, then it means that it's 80% important compared to all other features. Let's visualize this a little bit. Feature importance equals to pd.dataframe, and we'll take x.columns. We'll have model rf.feature importances. And then we'll have feature importance, and you can see it looks like this, and .t, and will look like this. We have transposed it, and we'll take .columns equals to, so let's change the column names. We change it to feature, comma, importance. Then let's do feature importance equals feature importance dot sort values and by importance. And we'll have ascending equals to false. We'll take a look into feature importances, and you can see here that, okay, CA is most important, and max HR, and then old peak, etc. Okay, now finally, let's do some plot to see how it looks like. SNS.bar plots, data equals to feature importance, X equals to importance, Y equals to feature. Okay, perfect. Semicolon. Here you can see that CIA is most important, and then max HR, etc. You see it in visually in this diagram. Yes, in this video we have worked with random forest in practice, hands-on using scikit-learn and working with the heart dataset. We have gone through just the basic scikit-learn steps, and finally we did some feature importances and made a data frame out of it and plotted it. Then we're done. Yes, and hope that you learned a lot from this video, and see you in the next one. Bye.